عزیز، خانم دکتر. من یک معرفی از به اصطلاح تحصیلات آکادمیک خانم دکتر داشته باشم و بعد با هم دیگه ارائه رو شروع بکنیم. خانم دکتر پردیس امامی-نائینی تحصیلات آکادمیکشون کارشناسیشون رو توی مهندسی کامپیوتر دانشگاه صنعتی شریف اخذ کردن. بعد کارشناسی ارشد علوم کامپیوتر رو در دانشگاه کارنگی ملون و علوم دکترای علوم کامپیوترشون رو هم مجددا همون دانشگاه کارنگی ملون گرفتن. سوابق علمیشون رو اگر بخوام بگم، یه پسادکترا در مورد نگرانی‌های حریم شخصی و امنیت کاربر در دانشگاه واشنگتن و پسادکترای دومشون رو داخل همون دانشگاه کارنگی ملون گرفتن. ایشون همین الان استادیار دانشگاه دوک هستند و از افتخاراتشون مقاله گزیده IEEE SMP برای برجسته شدن در مجله IEEE SMP سال 2021 هستش. خانم دکتر خیلی خوش آمدید. فکر می‌کنم که میتونیم با هم دیگه ارائه رو داشته باشیم. خیلی ممنون از شما. دوستان، من یک لینک گوگل فرمی رو داخل چت باکس براتون قرار میدم. سوالاتتون رو در طول ارائه میتونید اونجا وارد بکنید برای ما. تا قبل از تمام شدن ارائه لطفا سوالاتتون رو وارد بکنید. در انتها من سوالات رو از خانم دکتر تا زمانی که فرصت داریم میپرسم. متشکرم از شما.
دستتون در نکنه. شما الان میبینین همچنان پرزنتیشن رو؟
بله همه چیز درسته، میتونیم شروع بکنیم.
مرسی، ممنون. فقط یک لحظه صبر کنین، من یه لحظه چیزی رو عوض کنم. ممنونم، دستتون در نکنه. من پرزنتیشن رو به زبان انگلیسی میرم و در آخر سوال اگه دارین به زبان فارسی، به زبان انگلیسی، هر کدوم که براتون راحت تره، ولی من اصل پرزنتیشن رو به زبان انگلیسی میرم. Okay, let's get started. Awesome. Thank you so much for the introduction. And okay, so let me start by giving a quick overview of my background. I obtained my bachelor's degree in computer engineering from Sharif University of Technology. I then got my PhD in computer science from Carnegie Mellon University. I did a postdoc in University of Washington, and now I'm an assistant professor of computer science at Duke. Now, maybe I can provide some more details about this journey. I started my undergrad studies in physics department here at Sharif. Then after a year, I switched my major to computer hardware engineering. I then applied to CMU to do my PhD in wireless sensor networks. But then after a couple of months, I realized that this proposed directions and projects are not something that I'm particularly interested in for my PhD. And then I switched my field to usable security or human-centered security and privacy in the School of Computer Science at Carnegie Mellon University. During my PhD, I did 2 internships. The first one was at Intel Corporation during the second year of my PhD. And the second one was in my last year of PhD in Microsoft Research. After PhD, I went to Seattle for a postdoc in Security and Privacy Research Lab in University of Washington. My postdoc was during the pandemic, so I met my postdoc mentors about 3 times in person, and the rest were all remote. After a year of postdoc, I went on the faculty job market, which was a 4 or 5 months of preparing applications, interviewing, some in person, some remote, and then going to the second visits for the places that I got the offer from. And after that, doing some negotiations for the offer. And finally, I chose Duke for my professorship. Here at Duke, my main affiliation is with Computer Science Department, and I have secondary appointments in Department of Electrical and Computer Engineering and School of Public Policy. My field of research is human-centered security and privacy, which is at the intersection of security, privacy, and human-computer interaction. This is a somewhat new field in most universities. Some colleges are currently actively doing research and teaching this topic. For example, CMU, University of Washington, Maryland, or University of Chicago. But this is still a new field, and more universities are starting to invest in this highly interdisciplinary topic. The main idea behind the field of usable security is that no matter how technically secure and protective your system is, if users are not able to use your system, you failed in protecting them. And maybe one example that many of us might be able to relate to is passwords. Each of us have been asked to create tens, if not hundreds of passwords, basically on the websites that they visit, on the services that they use. And password is supposed to protect a user from security breaches. But users are humans and they're not able to remember these passwords. So what they do, they write these passwords down on a paper.
عذرخواهی میکنم. فکر میکنم که اسلاید های شما جلو نمیره. ما هنوز اسلاید پروفشنال بک‌گراند رو داریم.
همچنان موتیویشنش رو بعد میرفتم، بعد میرم اسلاید بعدی. ولی الان که گفتین نه الان که گفتین بذارین من فقط لحظه ببینم که من میتونم عوض کنم جهتش رو، چون که من یه ذره سخته که کامپیوترم دقیقاً جلوم نیست، مثلا دوربین شما رو من نمیبینم. گفتم اگه لحظه صبر کنه که من ببینم اگه میتونم عوضش کنم راحت تره یه خورده برام.
بله.
یه لحظه فقط قبل از اینکه ادامه بدیم من اینو ببینم چجوری میتونم عوض کنم. شما همچنان اینو دارین میبینین؟
بله.
شما الان نوت هم میبینین یا نه؟
نه ما فقط صفحه پرزنتیشن رو داریم.
عالیه. خب پس پس آره همچنان من تو موتیویشنشم و الان یه خورده وقت دیگه بعد از یه ذره در مورد بک‌گراند گفتن میریم سر اصل تاک. یه ذره در مورد فیلدم توضیح بدم، فیلد جدیدیه و بعدش میریم سر ادامه تاکمون. Okay. Yeah, of course. Yeah. So my field of research is basically human-centered security and privacy. This field, not many universities do have such a field. However, it is more and more universities are starting to design the field, teach the field. And I talked about passwords, and password is one of the classic examples of usable security and privacy. Basically means that if a site is asking you for a most secure password and you basically follow a specific guideline to create that password, after a while after the challenge you created the password, and what you do as a user, you basically reuse that password for all the websites. And this is not secure. This is not a secure practice. So what a usable security and privacy researcher would ask is, how can we educate the users? How can we empower the users to make protective passwords? Or how can we design better password managers for users to basically use to store and create the passwords? In usable security and privacy, we use methods from diverse fields, including computer science, social sciences, economics, design, and policy. In this talk, I will focus on a research effort that I've started 4 years ago during my PhD, and I'm still working on that. The goal of this direction and the projects is to design a usable and informative security and privacy transparency for consumers and users of smart devices, such as smart security cameras, smart thermostats, smart speakers, TVs, and all of that. Okay. So let me now jump to the main part of the presentation by talking about toilets. Not regular ones, but the smart ones. We have very expensive smart toilets on the market enabled with Amazon Alexa that could light up, or even better, flush for you with your voice command. And we're going to have a very much basically smarter one in the market that is equipped with several sensors, including cameras that could identify you and collect your health-related information. This technology could be very useful in identifying health-related issues, but this could also pose a huge risk to users' privacy, especially if they're not aware of it. Just imagine a scenario that your inferred diagnosis is being shared with your employer or the insurance company without your knowledge. People are increasingly purchasing smart devices. However, despite the surge in purchasing them, consumers are concerned about the privacy and security of the smart devices they purchase. But the question is how much they can realistically do at the time of purchase to better protect themselves. Many of us have the experience of purchasing a smart device online or in a store. Now, I want you to remember the time when you were in the physical store or searched online for the smart device to buy. You probably saw the information on the price of the device or its technical specification, for example, its size or internet connectivity. But do you remember seeing any information about the security or data practices of the smart device at a time of purchase? The answer is probably no, because usually this information is nowhere to be found. When purchasing a smart device online or in a store, consumers are not able to make an informed purchase decision, as the information on the security and privacy practices of the smart devices is not readily available to them. So I use my human-centered security and privacy approach to identify what is needed. And the need that I saw here was to make this information available and usable at the point of sale. For that, I designed and evaluated a usable and informative security and privacy label for smart devices, similar to a nutrition label for food items. This research has also resulted in a significant policy and advocacy impact. A few months ago, following an executive order from the White House, NIST, National Institute of Standards and Technology, was commissioned to work with other organizations such as Consumer Reports and academic institutions to initiate a pilot program to design security and privacy labels for US consumers of smart devices. In the US, we are the only research group working on consumer-facing IoT labels. So I've been actively engaging with NIST and Consumer Reports to inform their efforts on designing the IoT labels. Although the IoT label is a very new concept in the US, we are currently seeing such labels in a few other countries, such as Singapore or Finland. Smart devices are being sold globally, so it is important for consumers as well as manufacturers to have a standard IoT security and privacy label. And to achieve this, as a member of the World Economic Forum Trustworthy IoT Coalition, I'm also involved in international efforts to develop standards for IoT security and privacy labels. I asked several questions and conducted several projects in order to design a usable and informative security and privacy label for smart devices. I will first talk about the initial version of our label that we designed and the study that we conducted with consumers of IoT devices to capture their feedback on the design label. Being convinced about the essence of having the labels for consumers, we then conducted interviews and surveys with security and privacy experts to identify the information that should go on these labels. After that, we asked, is the design, security, and privacy label effective in informing consumers' purchase decision-making? And finally, we asked how much consumers of smart devices are willing to pay, if any, to have this information, to have transparency available at the point of sale. Starting from the beginning, the first project that I conducted was to capture IoT consumers' attitudes toward having security and privacy labels at the point of sale. For the labeling efforts that I will talk about today, we conducted an extensive literature review and went through more than 70 IoT security and privacy references from academia, governmental organizations, both in the US, such as NIST, as well as international ones, such as DCMS in the UK and ENISA, nonprofit organizations such as Consumer Reports, as well as guidelines from companies, including AT&T, Intel, Microsoft, and Symantec. Based on these surveyed IoT security and privacy documents, we designed the first prototype of our IoT label for smart devices, as shown here. This label had 3 sections: general information, privacy information, and security information. We then conducted the study to explore IoT consumers' perceptions of our design label. Almost all of our interviewees reported that they would like to have such a label at the time of purchase. We also asked them how much of a premium they are willing to pay, if any, to have this information available at the point of sale. And they reported that they are willing to pay 10 to 30% of the base price of the device to be provided with this transparency, mainly because of the perceived assurance that their security and privacy would be protected, and also for peace of mind. From this study, we found that it is currently very difficult for consumers of smart devices to find information about the privacy and security practices of the devices at the time of purchase, and that they are very excited about the idea of having such labels at the point of sale. One of our participants said, as opposed to those long policy documents that you usually need to read, I think this is a very efficient way, and I cannot think of a better way than this. Several pieces of legislation have been proposed, some very recently inside the US and in a few countries outside of the US, including UK, Singapore, and Finland, that would require IoT labels. Some even mention a few factors that should be included in these labels. But these guidelines were not very specific about how these labels should look like. And as you can see from the titles of these policy reports, they're all focused on security practices without much attention to privacy and data practices. So our question here was, what should be included in an IoT security and privacy label? Okay, which is basically our next project. To capture a holistic view, we interviewed and surveyed a diverse and gender-balanced sample of security and privacy experts from industry, academia, government, and non-governmental organizations. The recruited experts had to satisfy at least one of the following criteria: being a faculty member in the field of privacy and security, having more than 10 years of research or practice in security, privacy, or policy, being an author of known books in the field of privacy and security, having active involvement in cybersecurity standardization, or leading an IoT product team in industry. To elicit experts' opinions on the privacy and security factors, we followed a 3-round Delphi process. In the Delphi method, the objective is to reach a consensus among a panel of experts without these experts directly influencing each other's opinion. We reach this consensus among experts after 3 steps. The first stage of the Delphi process is mostly an interview study. We conducted semi-structured interviews with experts. We asked them what security and privacy factors they think consumers should know about when purchasing a smart device. Based on these interviews, we found 47 factors that at least 2 experts wanted to see on the label. We then conducted the first follow-up survey, where each expert was randomly assigned to review 1/3 of the attributes to specify their importance, as well as their reasons supporting their decisions. From this stage, we found the reasons why experts would like to include or exclude a factor from the label. In the Delphi process, we have this concept of controlled feedback process, which means that the aggregate output of the previous stage will serve as the input to the next stage. And we have this feedback loop to allow experts adapt their responses and eventually converge. As part of this feedback process, we presented the aggregate output of the survey 1 to experts on survey 2. Here again, each expert was randomly assigned to review 1/3 of the attributes. And once again, we asked them to specify whether they would like to include or exclude the factors after seeing all the reasons from the previous stage. Okay, experts acknowledge the value of the label in informing consumers' purchase behavior. An expert mentioned, what's good about a label is that it empowers the consumer to make a more active decision about cybersecurity rather than just being completely helpless as to what the security of her device might be. The average consumer doesn't have a privacy, security, or legal department to review this stuff before they buy it. Enterprises do, but consumers do not. So someone's got to be looking out for consumers and giving the consumers this information. In addition to informing consumers' purchase behavior, some experts predicted that if the labels get adopted, this could initiate a competition in the market for device manufacturers to improve their practices. An expert said, there is value in forcing the company to write a list down, even if the consumer doesn't understand it. If you said, list your open ports, there would be an incentive to make them few. Our experts wanted us to include 47 security and privacy attributes on the label, which is clearly too many to show on a typical product package. Therefore, we decided to design a layered label with 2 layers. The primary layer, which is on the left, is this concise format of the label, which could be printed and attached to the package of the smart device. Then there's a QR code and URL at the bottom that direct consumers to the secondary layer, which has more detailed information, and it is in an online-only format that can be updated as firmware changes, which is critical as devices get updated often. Another important reason to have this online layer is to have a way to accommodate companies updating their security and privacy practices. To assess our label's usability and information communication, we recruited 15 consumers from Pittsburgh, which was where I was basically doing my PhD in. We only included consumers who have purchased at least one smart home device. We then conducted 1-hour semi-structured interview with each participant. We compensated each participant with a $25 Amazon gift card, and by following a user-centric design process, we assessed and iteratively improved the usability of our label. We tested the label's risk communication and information comprehension in both non-comparative and comparative purchase process. We started with the non-comparative process and asked our participants to take a look at the package of the smart device with our label on and define the attributes as well as their values. We then conducted the comparative purchase process. We asked participants to take a look at the smart device from 2 different companies, compare the labels, and tell us which company had implemented better and more protective security and privacy practices and why. Most of our expert participants believe that consumers would find the layered design of the label to be confusing. However, in our user study, only a few participants preferred having a single layer security and privacy label, mainly because of the inconvenience of using their phone or a QR code scanner to see the secondary layer, and also this feeling that a company is hiding some information from the consumers by presenting this on the secondary layer. Most of our participants, however, preferred having a layered security and privacy label, mainly because a layered label would fit more useful information about the privacy and security practices of the device manufacturer. As we expected, some of the information on the secondary layer was not understandable to some consumer participants. For example, devices, ports, and protocols. However, consumers told us that they still would like to see this information on the secondary layer to be as informed as possible when purchasing a smart device. One of our participants said, I don't know what TCP and UDP are, but it's interesting to have this here because then I could go to Reddit and ask under what that means and what the capabilities are. Some of our consumer participants reported that this label is useful to inform both consumers as well as experts. A participant said, labels are both for customers and experts, such as tech journalists and consumer advocacy groups. If they see something that is questionable, they will raise it in the public press or will raise it with regulatory authorities. The label is not just for the consumer, but there's another feedback process that works through experts. In an iterative process, we applied several wording and design changes, and this is the next version of our label. We then conducted another project to basically understand whether this label is effective in conveying risk to consumers and influencing their purchase decision-making. Okay, so how did we assess risk perception and willingness to purchase? We conducted a survey, and in this survey, we asked participants to imagine purchasing a smart device with a security and privacy label. The label talked about only one security or privacy attribute value. Each participant was assigned to answer questions about 3 purchase vignettes. This is an example of a vignette that we show to participants. The words inside the brackets are the factors that we vary among scenarios. Imagine you're making a decision to purchase a smart speaker with voice assistant for yourself. This device has a microphone that will listen and respond to your voice commands. The price of the device is within your budget, and the features are all what you would expect from a smart speaker with voice assistant. On the package of the device, there's a label that indicates the following privacy and security practice: purpose of data collection, tailored advertising, and monetization. At the end of each scenario, we ask participants to specify on a Likert scale how each attribute value would change their risk perception and willingness to purchase, and why. In this study, we selected only a subset of label attributes to test. Especially, we only included the attributes with concrete values as opposed to a hyperlink. So these are the ones that only had a hyperlink, but these are the ones with concrete, basically, values that we can test. For each attribute of the label, we selected 2 values, which we hypothesized to be the most protective and least protective. For example, for the purpose of data collection, we provided main device function as the most protective value, and we considered monetization as the least protective value. We hypothesized that most protective values of attributes should significantly decrease the perceived risk and increase willingness to purchase, and we expected the opposite for the least protective values. We then launched a large-scale study on Amazon Mechanical Turk, which is a crowdsourcing platform. The survey that we conducted had a mixed design, which means it had both between subjects and within subjects factors. We considered 2 between subject factors of device type, device recipient. For device type, we considered 2 levels: smart speaker, smart light bulb, which has varied risk profile. Device recipient, we considered 3 levels for device recipient: purchasing a device for yourself, for a family member, or for a friend. The within subjects factor, which basically means the factor that all participants saw in this survey, was a security or privacy attribute value. Using these factors, we then basically generated several hypothetical purchase vignettes, each asking participants to imagine purchasing a device type for a device recipient with a specific security or privacy information. At the end of each scenario, in 2 questions, we asked them to specify how that attribute value would change their risk perception. In the second question, their willingness to purchase. We then constructed 2 cumulative link mix models, or CLMM, to basically understand, explain how different factors would change participants' risk perception and their willingness to purchase. Okay, so based on the coefficients in the regression models, we were able to basically understand the impact of device type, device recipient, and security and privacy factors on risk perception and willingness to purchase. Here we found that participants perceived a significantly higher risk for smart speaker compared to a smart light bulb. And this beta is basically the model coefficient. And they were significantly less willing to purchase a smart speaker compared to a smart light bulb. The second between subject factor was the device recipient. And the regression model showed that the device recipient had no significant impact on participants' risk perception. However, participants were significantly less inclined to purchase a smart device for their friends compared to themselves. We qualitatively analyzed, coded why this is the case. We asked some open-ended questions, why to understand their reasoning behind their desire to purchase. And we found that participants frequently mentioned that friends should decide for themselves if they would like to introduce a specific level of risk to their home. And they're basically not in the place to make that decisions for them. And that's why they're not willing to purchase a smart speaker or a smart device for their friends. The CLMM or cumulative linked mix models indicated that the impact of almost all tested security and privacy attribute values on risk perception and willingness to purchase were as we hypothesized, meaning our hypothesized most protective values significantly decrease the perceived risk, increase willingness to purchase. And the least protective values significantly increased risk perception and decreased desire to purchase smart devices. Based on the factor coefficients or the betas from the regression model, we ranked the effectiveness of each attribute value in terms of changing risk perception and willingness to purchase, starting with the risk perception. The top three factors that significantly increased the perceived risk were selling data to third parties, having no control over access, and sharing data with third parties. And the top three factors that significantly decreased the risk perception were having multi-factor authentication, no data sharing, and having no cloud retention. We did the same thing for willingness to purchase, and the results were somewhat very similar. The top three factors that significantly increased participants' desire to purchase smart devices were no data sharing, having no cloud retention, and having no device retention. And the top three factors to decrease participants' willingness to purchase were sharing data with third parties, having no control over access, and selling data to third parties. We also noticed a few security and privacy misconceptions. For example, some participants thought that having no security updates, for example, if the label is telling them that the device does not receive any security updates, that basically means that the device is more secure, as it does not need to be updated. A participant said, if there are no updates, then the system must be providing maximum security already. Another misconception was related to mentioning the average time to patch, which we had on the label. Even mentioning the word patch, some participants believe that the device is not secure, as it needs to be patched. A participant said, on the label, it advertises that patches are even needed. That is why there is a perception of decreased privacy. Based on inputs from experts and consumer participants, we applied further changes to the content and design of the label, and this is the most recent version of our label. Okay, so we just basically talked about the fact that consumers would like to have a label. We talked about how to design a label. We assessed the risk perception, willingness to purchase. And now the final question that we asked was basically to understand how much consumers are actually willing to pay to have this information, to have transparency and improved security and privacy for their smart devices. And this is an important question to ask in general, because there are several device manufacturers that currently do not have security and privacy resources and experts and infrastructure. So just understanding whether consumers are willing to pay a premium, that could be an incentive for these manufacturers to improve their practices. Okay, so to elicit consumers' true willingness to pay, we designed an incentive-compatible experiment using multiple price lists, MPL. MPL is basically a table with a list of rows, where each row participants is basically being asked to choose the device on the left or the device on the right. Each option basically shows a value of a coupon that the consumers would get if that row is being selected. The left option in this table will always stay the same throughout the table. And the coupon amount for the option on the right would decrease in equal increments from top to basically the bottom row. And the idea here is that the left option is the device with risky security and privacy practice. The right option is a device with more protective practice. Here, the right is a device that receives automatic security update compared to no security update. And the idea here is that a reasonable user would start going from right to left. And basically here we are looking for a switching point. And based on that switching point, we can basically analyze the amount that consumers are willing to pay to have that improved security or privacy practice. There are a lot of more details about how we designed this experiment to be incentive compatible. So if you're interested in this, I would be happy to chat about this after the talk. When we found that switching point from the MPL, from the multiple price list, we then analyzed this by constructing interval regression models. And based on that regression models, we were able to basically rank the value, the monetary value of each security and privacy practice, of each improved security and privacy practice. The top 3 most valuable security and privacy improvements are having de-identified cloud storage compared to identifiable cloud storage, changeable default password compared to having no access control, and having multi-factor authentication compared to no access control. And the numbers in front of each practice is basically the dollar value, the premium that consumers are willing to pay. The base price of this device was $60. So that is basically means $13 on top of $60. And it was a smart speaker. And the least valuable security and privacy improvements were having no cloud storage compared to identifiable cloud storage, having automatic security updates compared to manual security updates, and having changeable default passwords compared to multi-factor authentication. Our results showed that security and privacy are in general valuable to consumers of smart devices, and they're willing to pay a significant dollar amount to have that at the time of purchase. But this was not always the case. We also surfaced a few competing factors, including functionality and usability. For example, in terms of functionality, we hypothesized that consumers would be willing to pay significantly more for having no cloud storage, as opposed to a device with de-identified cloud storage. What we found here is that although consumers perceived having no cloud storage as more protective, less risky as having cloud storage, but they were willing to pay significantly more for having the functionality of the cloud. So that is one competing factor. The second was usability. We hypothesized that consumers are willing to pay significantly more for having multi-factor authentication than a device that requires password. But still, that was not the case. Consumers were willing to pay significantly more for having a device with changeable default passwords compared to multi-factor authentication. And the main reason for this was that 2FA, two-factor authentication, or multi-factor authentication, these were not usable and convenient for consumers to use. So they were not willing to pay for them. We also looked into the monetary value of security and privacy features when they're being presented holistically on the label, not just one at a time. Our quantitative analysis showed that consumers are willing to pay a significant premium for a smart device with improved security and privacy practices. So if you show them the label that everything there shows that the device is most protective, definitely they're willing to pay more for that. But what was surprising in this study was that consumers are willing to pay significantly more for no information, having no information about security and privacy, compared to purchasing a device with a label that basically presents least protective security and privacy practices. So they prefer no information compared to a device with bad security and privacy. And what this tells us is that device manufacturers with insecure devices, with risky basically devices, they might not be willing to disclose this information at the time of purchase because they already know that consumers may not be willing to pay for them. And what we propose here is to have mandatory IoT labels for them to be effective. We believe that voluntarily IoT labels are not effective. In addition to the label, we prepared a specification document for consumers and IoT manufacturers. In the specification, we provided the full taxonomy of the label, consumer explanation for each factor on the label, as well as a list of best practices for device manufacturers on how to better implement these security and privacy features. For real-world impact, we would like to have our labels adopted. And to ease the process of generating the labels, we developed an interactive tool that allows users to complete a form for different sections of the label and then see the label being generated in real time. In the most current version of the tool, users can download the label in the formats of JSON, XML, and HTML. Users can also work on these labels offline and then upload the saved JSON file to resume working on it. We are still actively working on the IoT labeling front. On the research side, we are now exploring how we can design a transparency tool, a label, security and privacy label for connected medical devices to inform the privacy and security decision-making of patients as well as healthcare providers, for example, for pacemakers. In addition, we are looking into designing an informative tool, an informative label for autonomous vehicles. On the policy and advocacy side, we recently presented our label research in the White House National Security Council. And together with other stakeholders, including NIST, CTA, Consumer Technology Association, we are working on designing a national security and privacy label in the US. And last but not least, I'm currently a consultant. I'm currently working with Consumer Reports to recruit device manufacturers to pilot our label on actual smart devices so that we can assess the efficacy of the label in real purchase settings. To summarize the label project, smart devices are not transparent about their privacy and security practices, and a label could be useful to provide that much in the transparency and inform consumers' purchase behavior. To specify the content of the label, we conducted interviews and surveys with a diverse sample of privacy and security experts from different organizations. We then conducted a series of user studies with consumers of smart devices to evaluate the efficacy of our label in informing consumers' purchase decision-making. To ease the process of generating and adopting the label, we prepared a specification document and a tool to basically generate the labels. Everything about this project, including the label generator, the specification, and the papers that we published, are all available on our IoT website, iotsecurityprivacy.org. And basically, these projects that I talked about, it was just a summary of several projects that we are currently working on to design the IoT labels. In this talk, I mainly focus on the security and privacy needs of average consumers of smart devices and average basically users. In addition to basically average users of technologies, in our Inspire Lab, Interdisciplinary Security and Privacy Research Lab at Duke, we have several ongoing projects to investigate the security and privacy concerns and expectations from an inclusive perspective. For example, two populations that I very recently started looking into are the victim survivors of intimate partner violence and the economically marginalized and disadvantaged city neighborhoods. starting with the victim survivors of IPV, intimate partner violence. I'm designing a study to understand the security and privacy needs and concerns of people who have experienced IoT abuse. One example of this type of abuse is that when the abusive partner is using the security cameras to spy on the victim survivor without their knowledge. Using this obtained knowledge of needs and concerns, I will then design security and privacy solutions to inform the victim survivors of the potential IoT abuse and educate them on how to better protect themselves against such risks. In addition, I want my research to provide a guideline for IoT device manufacturers as well as policymakers to more effectively protect the victim survivors of IoT abuse by designing IPV-aware technologies and regulations. We also recently started a basic project on surfacing the security and privacy knowledge and concerns of the most underserved neighborhoods of Seattle towards smart city technologies, including security cameras, smart air quality sensors, and gunshot detectors. Based on the findings, we provided several recommendations for various stakeholders, including device manufacturers and city policymakers, to design people-centric and protective smart cities. A few more ongoing projects that we are basically currently working on. The first one is to understand the current privacy and data practices, basically the landscape of privacy and data practices of decentralized social networks, especially Mastodon, which is the use case that we are basically looking into. In this work, we are crawling the Mastodon servers to explore what data practices they promise in their privacy policy and how much users of such networks understand these data practices. In addition, we are designing a tool to help users find a server that best matches their privacy preferences. Another project that we are working on, which is in collaboration with Northeastern University and University of Washington, is to understand how visual and audio interfaces are currently manipulating users by, for example, making it harder to opt out from data sharing or data collection, or not providing them with enough information to make an informed privacy decision, which is basically dark patterns or manipulative patterns. Another research effort is that we are currently working on in the lab is basically to look into social VR, virtual reality, and our focus is to basically understand how parents perceive the risks, the ethical risks, as well as security and privacy risks of social VR for their kids when they interact with such technologies. And what we want to basically do is that we would like to design features that parents would like to have to better protect their kids when using social VR. Finally, we just started a project to understand how the current security and privacy tools, such as privacy policies, password managers, or anti-phishing mechanisms, fail neurodiverse individuals, for example, people with ADHD or autism. We have several other exciting projects in the lab, which I would be happy to chat if you're interested. With that, I would like to conclude my talk, and I would be happy to answer your questions now in Persian or English. Thank you very much for your attention.
How are different groups of consumers' perception of privacy and security and needs satisfied? Are the labels drivers enough?
Yeah, so that's a great question. So the label is just a transparency tool. basically, I think this question is similar to say whether nutrition labels are enough for people to adopt healthier, basically, practices, to eat healthier foods and all of that. So I think we need to have transparency. We need to show them what's going on with these devices, for example, with the smart speaker, with cameras and all of that. But we also need to improve the security, privacy of the devices themselves. So I think this should not replace the technical, basically, practices, the technical improvements that we are currently doing for these devices. But this is on the education side. This is on the transparency side that should accompany such improvements on the devices themselves. For example, there were news articles coming maybe a few weeks ago saying that smart thermostat do have microphone, but the device manufacturer did not disclose that these devices have a microphone, and users have no idea that their thermostat might have a microphone. So these are things that we think users should know about to better protect themselves, but at the same time we need to improve the devices themselves.
یکی دیگه از شرکت کننده ها پرسیدن که در اون لیبل هایی که داشتیم زمانی که کامپنی میاد و اون پالیسیش رو آپدیت میکنه، آیا این آپدیت کردن ممکن نیست باعث این بشه که اون کاربرها یا اون مصرف کننده ها ناراحت بشن یا پشیمون بشن از خرید اون محصول؟
بله، خیلی سوال خوبیه این. وقتی که خب کلا هدف ما واسه این پروژه اینه که وقتی که لیبل داری، وقتی که لایه دوم این لیبل وجود داره، هر موقع که عوض میشه، هر موقع که مانیفکتچر آپدیت میکنه هر کدوم از پرکتیس ها رو، یوزر باید نوتیفای بشه، یوزر باید نوتیفیکیشن بگیره که اینا عوض شدن و این جزء قانونی هستش که الان اینجا دارن میذارن توی رگولیشن هایی که واسه لیبل میذارن. یکی از پوینت هاش اینه که باید یوزر نوتیفای بشه. ولی حالا این که وقتی که یوزر نوتیفای شد میتونه دستگاه رو عوض کنه یا نه، میتونه ریپورت کردن چیزی هستش که انجام میشه، میتونن ریپورت کنن، ولی اینکه بعد رو ریپورت چه نتیجه‌ای میگیرن این چیزی نیستش که ما توی رگولیشن داشته باشیم و شاید بهتره که داشته باشیم. ولی الان اگه اون پرکتیس عوض بشه و شما ناراضی باشین از دستگاهتون، به نظرتون اون سکیوریتی که می‌خواستین رو نداره، میتونید ریپورت بدید و میتونید دستگاه رو استفاده نکنید. ولی اینکه حالا مانیفکتچر چیکار براتون میکنه، این چیزی که به هر مانیفکتچری جدا ربط داره، چیزی نیستش که یه پالیسی وجود داشته باشه که همه‌شون مثلا ازش پیروی کنن.
یکی دیگه از شرکت کننده ها پرسیدن که حالا به انگلیسی نوشتن، من هم میخونم. گفتن که you mentioned creating labels for informing the customers and in slides 18 and 19 you mentioned the motivation for the labels, which is that they are necessary since the customers can't review the possibility already existing legal documents without the help of legal departments. My question is, as recent work have used ML models such as GPT to help users understand legal models, do you see potential in using GPT for automating the generation of the labels for the future work? How would you how would you integrate it in your process? For example, to provide additional comments to the users asking clarifying information on security privacy with the chatbot interface.
Yeah, that's a very interesting question. So I would say that these language models, what they can do is that if you have these, for example, privacy policies available out there, they may be able to make them more usable to consumers. They may make the wording more usable, for basically more understandable to users, which is still very valuable. I think what they cannot do and what is probably missing here is that device manufacturers themselves are also not transparent about their practices. So it's not really the case that such information is out there and we are just trying to make it more usable. The challenge here is to basically make the device manufacturers liable for this information, liable for the security and privacy practices, and ask them to disclose what they're doing. Definitely, there is not a guarantee that they are not lying in it. They are not basically providing false information. But still, I think what these language models can do is that if the information is out there, they can provide it in a more usable format. based on basically this interaction with the users, what information they don't understand, what additional information they want, and all of that. But I think the main issue is that this information is not really available, and we need to force the manufacturers to provide the information.
یکی دیگه از شرکت کننده ها پرسیدن که آیا در مورد خودروهای الکتریکی هم این مباحث پیاده شده و ریسرچ روی اینها انجام شده یا نه؟
این چیزی که ما میخوایم انجام بدیم انجام نشده و چیزی که الان هسته، چیزی که الان توی قانون قراره بذارن فقط در مورد اسمارت هوم دیوایس هست، کاملا ترادیشنال، اسمارت سپیکر، ترموستات، کامera، تیوی، هر چیزی که تو خونه هستش. حتی اسمارت واچ و اینا هم حساب نمیشه توی اینا و حتی مدیکال دیوایس هم حساب نمیشه. ولی از یه جا قرار شروع بکنن و اون جایی که قرار شروع کنن اسمارت هوم دیوایسه. ولی ما الان داریم فکر میکنیم که مثلا کانکتد مدیکال دیوایس ها مثل پیس میکر، مثل سمارت واچ، دستگاهی که اینجکت میکنن، تزریق میکنن مثلا دارو رو، و همه اینا قابلیت هک شدن دارن و خیلی هم راحت هک میشه چون خیلی دستگاه کوچیکن، کامپیوترشون ریسورسشون خیلی کمه، انکریپشن ندارن خیلیاشون و همه اینا. ولی یوزر نمیدونه، پیشنت نمیدونه که همچین اتفاقی میفته، دکتر هم نمیدونه، واسه هم نمیتونن کمک کنن پیشنت رو چه دستگاهی رو انتخاب کنن. بعضی وقتا مثلا هیچ چویسی وجود نداره، ولی اگه چویس باشه نمیتونن درست انتخاب کنن. و کاری که ما الان داریم میکنیم یه دیرکشنی که داریم روش کار میکنیم کانکتد مدیکال دیوایس هست و یه دیرکشن دیگه هم اتونومس ویکل، اسمارت کار هست و به نظر ما هر دوشون مهمن، هر دوشون در آینده قرار مهمتر بشن، ولی این چیزی نیستش که حداقل با توجه به چیزی که من میدونم دانشگاه دیگه ای روش کار کنه یا گروه دیگه ای روش کار کنه یا اینکه حتی تو قانون در موردش حرفی زده بشه. ولی مطمئنا چیزی که در آینده بهش خواهیم رسید و واسه ما الان داریم سعی می‌کنیم این ریسرچ رو انجام بدیم.
پرسیدند که Is it possible to add a feature in survey that the device has passed an ethical hacking challenge and can it affect the premium?
Yeah, that's interesting. So some of these device manufacturers, there is this program that bite basically hackers or bite basically I don't exactly know the terminology that they use, but basically these are hackers that try to find vulnerabilities in devices before the bad hackers would find them, which is I think what you're kind of maybe referring to, this ethical kind of challenge. So some manufacturers do have such a program that as a hacker, as a void hacker, you can basically try to find the vulnerabilities and you may get paid for that. So basically this is kind of a challenge, it's a kind of a security challenge that they have. And the information about that, if that basically, and the name of that program is Bug Bounty Program. If that program is available, we provided that information on the label on the secondary layer. We don't really talk about the details of that, but there is a link to this Bug Bounty Program. And then the user, the consumer can then basically see what was the challenge, what vulnerabilities were found, and all of this. But we already have that feature on the secondary layer. And you also ask about the amount of premium that consumers are willing to pay. So basically, the way that we measure the premium was about the information that was on the first layer, not on the secondary layer. So we don't really know about the secondary layer, whether those are valuable to consumers, because the idea is that some of them are not understandable to them, but we still have them for experts. But we measure the premium only for the ones that were on the first layer.
به عنوان سوال آخر گفتن که شما در یه اسلایدی فرمودید که یک سری جاها کاربرها فانکشنالیتی رو در واقع ترجیح میدن نسبت به اون ریسکی که قرار اون دستگاه داشته باشه. گفتن که آیا این دیتا شیرینگ اگر که توضیح داده بشه که میتونه باعث کاربری بهتر بشه، مثلا در الگوریتم های فدریتد لرنینگ استفاده بشه برای تجربه کاربری بهتر، آیا این هم باعث نمیشه که خرید اون کالا ارزش بیشتری پیدا بکنه و بیشتر برن ملت به سمت خریدش؟
بله، خیلی سوال خوبیه. خب کلا اینه که ما یه فاکتوری که داریم همچنان توی لیبل targeted advertisement که شما دیتا رو شیر کنید واسه پرپس targeted advertisement، یا مثلا یا فیچر هایی که مثلا فقط با شیر کردن دیتا میتونیم بهش برسیم و مین فانکشنالیتیش نیستن. و چیزی که فهمیدیم اینه که خیلی از کانسومرها هستن که حاضرن پول بدن واسه اون ادیشنال فیچر. واسه خیلی‌ها این چیز خوبیه، نه واسه همه. بعضی اینطوریان که خب پرایوسیشون به خطر میفته، دیتاس همچنان که داره میره ترد پارتی اینوالو هست و خب حاضر نیستن که دیتا واسه همچین قضیه شیر کنن. ولی یه سری کانسومر هستن که حاضرن. ولی شما پوینت دیگه‌تون که گفتین اینه که اون پرپس رو بهشون بگی که دقیقاً واسه چی استفاده میشه. حالا فدریتد لرنینگ که گفتیم فکر کنم میشه گفت ریسرچ، حالا به صورت به طور کلی اگه ریسرچ باشه، پرپس ریسرچ ما اینو امتحان کردیم و دیدیم که کانسومر به نظرش ریسرچ چیز مهمیه و حاضرن براش دستگاه رو بخرن و یه پریمیومی براش خرج کنن واسه اینکه این فیچر رو داشته باشن. ولی خب بازم مهمه که این ریسرچ کی ازش بنفیت میبره. مانیفکتچرر بنفیت میبره، ترد پارتی بنفیت میبره، گاورمنت بنفیت میبره و همه اینا یه سری دیتیلن که باید مشخص بشن و اون موقع کانسومر میتونه تصمیم بگیره. ولی اینکه مثلا فقط بگیم ریسرچ چیزیه که خب واسه کانسومر کافی نیست. اطلاعات خیلی بیشتری میخواد واسه اینکه ببینه که حاضره که دیتا رو شیر کنه. و این کلا در مورد هر چیزی که شما ثرد پارتی رو اینوالو میکنی یا در مورد یه پرپسی حرف میزنین که پرپس اصلی دیوایس نیست، باید کلی اطلاعات بیشتر به کانسومر بدین تا بتونه این تصمیم بگیره.
حالا سوالی که من خودم الان به ذهنم رسید، آیا مانیفکتچرها حاضر هستند که دو مدل از اون محصولشون رو بدن که مثلا یه محصول دیتا شیرینگ داشته باشه و یه دونه محصول و همون نسخه از محصول بدون دیتا شیرینگ؟
کلا من کلا فکر میکنم که وقتی که ما در مورد مدل پریمیوم داریم صحبت میکنیم، مثل خب هر سرویس دیگه، یه مدلش هست که بیسیکه، یه مدلش هستش که شما یه ذره فیچر بیشتر میگیرید ولی خب یه پولی هم باید بدیم. حالا اون فیچر میتونه سکیوریتی پرایوسی باشه، میتونه این باشه که یه مدل مثلا الان کانسومرها میدونن که واسه چی اسمارت تیوی ها اینقدر ارزونن در مقایسه با تیوی عادی، اینقدر پولش کمتره، چون میدونن که اون دیتایی که دارن شیر میکنن اون دیتا پوله، اون دیتا چیزیه که مانیتایز میشه. واسه همین شما اگه به عنوان مثلا مانیفکتچر اسمارت تیوی بگین که من دیتا شیر نمیکنم با ثرد پارتی ولی خب پول بیشتر میگیرن رو دستگاه، این چیزی که ما فهمیدیم که کانسومر حاضره که پول بیشتر بده چون میخواد که دیتا شیر نشه اگه فیچر خاصی نمیگیره. حالا اگه برای فیچر مهم باشه اون یه بحث دیگه است. ولی کلا به نظر ما در آینده مدل های مختلفه، مدل بیسیک، مدلی که شما یه ذره فیچر داره یه ذره بیشتر پول بدید و لایه‌های مختلف سکیوریتی. ولی خب به نظرم واسه مانیفکتچر چیزی هستش که پول میتونه ازش به دست بیارن و به احتمال خیلی زیاد این کارو انجام میدن.
خیلی متشکرم خانم دکتر از اینکه وقتتون رو در اختیار ما گذاشتین، ارائه عالی رو دادید و همه سوالاتم پاسخ دادید. خیلی متشکرم.
ممنون که دعوت کردید. بازم اگه هر کی سوال داره، ایمیل من بود رو صفحه، ولی pardis@cs.doc.edu هر سوالی دارید بپرسید. اگه میخواین بیشتر بدونید در مورد همه این پروژه ها، من خیلی خوشحال میشم در موردشون حرف بزنم و بازم مرسی که دعوتم کردید.
خواهش میکنم. شرکت کننده عزیز، ما لینک فیدبک پرزنتیشن رو داخل چت باکس گذاشتیم، لطف بکنید حتما شرکت بکنید و فالو بکنید. هم این برای ارائه های بعدی به ما کمک میکنه، هم ما این فیدبک ها رو برای پرزنترهای عزیزمون میفرستیم. متشکرم. شب خوبی داشته باشید. خدا نگهدار.